Hi friends, this is PH3501 Unit 1 Solid State Physics by Dr. M.R. Gadhvi. We have seen in the previous lecture about the unit cell and the lattice parameters and what exactly the mean of crystals. We have seen that crystal, that means a very nice definition given by the Charles Kittle, that is lattice plus basis, that is what the crystal. Lattice, that means it is a mathematical concept where you having a 3 coordinate axis orthogonal to each other. In general it is a Cartesian coordinate system, and therefore you having a 3 lattice vectors a, b and c along the axis x, y and z respectively, and the angle between them, that is a 3 interfacial angles which are said to be alpha, beta, gamma, as it is shown here. In between a and b, that is a gamma, between b and c, that is alpha, between c and a, that is a beta. So this 6 are said to be a lattice parameters. 3 are the vectors, 3 are the angles. A, b, c the vectors, and alpha, beta and gamma are the interfacial angles, that is known as lattice parameter. The unit cell is basically the smallest fundamental blocks which is periodically repeated throughout the axis, and that makes the crystal. So on a lattice, a group of atoms are periodically repeated. So group of atom are represented by the bases. So this group of atom, let us say you assume that this is a chunk of a group of atom, maybe in a corner, maybe in a center, maybe somewhere, but this is the parallelepiped are showing here, that is a group of atoms. So this is said to be a basis. In addition to that, this having a specific geometry, and on each coordinate axis, with reference to each coordinate axis and the alpha, beta, gamma, we can point out the position of atom. So the tool which we help us to point out the atoms, which is said to be a lattice. Okay, and the smallest group of the atoms which is periodically repeated, which are said to be a unit cell. So unit cell is the smallest portion of a crystal which is periodically repeated. Okay, so with this previously understanding what we have seen in the last lecture, in addition to that we have also underlined the unit cell. Let us look at that. The primitive cell and non-primitive cell shown over here by P and NP. So it is written very clearly, the primitive cell must have only one lattice point. As for example, here we having a lattice of a 2-dimensional, where we having a one y-axis, another is the x-axis. So we have chosen a one parallelogram over here, where the 4 atoms are on each corner, right? Now this is a 2 axis, so one atom is divided into the 4 zone. So 1/4 of atom is belong to this region, and 3/4 atoms are outside this chosen box. So 1/4 on this corner, 1/4 on this corner, 1/4 on this corner, and 1/4 on this corner. That means 1/4 region of 4 corner atom of each 4 corner atoms are belong to the chosen area. So ultimately 1/4 into 4, that is a 1 atom is belong to that. So if such chosen blocks is there, or chosen basis is there, or chosen building block is there, so such unit cell where you having only one lattice point, you can see this is 1/4 point, 1/4 point, 1/4 point, 1/4 point, summation of 1/4 plus 1/4 plus 1/4 plus 1/4, so that is a one lattice point. So such unit cell is said to be a building. The 2-dimensional I can show it to 3-dimension. Now this is the actual thing, this is a hypothetical just for understanding. Now this is where you having a 8 corners, one such kind of a parallelogram on top, one is on bottom, and 4 on the faces. So that makes 6 faces make a one unit cell, which is actually existing in our system. So now you having a 8 points are there, 4 on top and 4 on bottom, and since there is a 3 axis A, B and C, lattice parameters, or which is parallel to the x, y and z axis, and therefore the each atom is divided into the 8 part, where the 7-8 portions are outside, but 1/8 portion will be inside the box, inside the unit cell. So 1/8 multiplied by 4 plus 4, that is 8. So 8 multiplied by 1 by 8, so that will be again a 1 unit cell, 1 point, and therefore this in 3 dimensions also you having a availability of a 1 lattice point. Therefore this is said to be a primitive unit cell. But look at here, this primitive, this primitive, this primitive. Over here there is no atoms on a corner. So it is not necessary that atoms must be at the corner. Ultimately the definitions are as per the lattice point should be 1, or available number of atoms contribution also 1. Then you can say that it is a pure unit cell which is primitive. But over here you can say 4 are on corner plus 1 in the center. As for example, let us say you are knowing in a cubic unit cell there is a one of the nomenclature you have given, that is a BCC, body centered cubic. So let us assume that 4 are on the corner and 1 is atom at the center. Let us say यहाँ पे अगर आप वही analogy रखो तो 4 on top, 4 on bottom and 1 atom is in, let us assume, in the center. So ये जो क्यूब है वो बॉडी सेंटर हो जाएगा. ये बॉडी सेंटर में आप क्या सोचोगे कि 8 on a corner atoms or the lattice points are available. So 8 multiplied by 1 by 8, so it become 1, and 1 is in center, so it become 1 plus 1. So it's a 2 atom carries by this one, if it is the case of the body center like this. Over here in 2 dimension you look at that 4 on the corner, so that is 1/4 of each one multiplied by 4, so it become 1 plus 1 whole atom is inside, or a 1 whole lattice point is inside. So ultimately it carries 2 lattice point, and therefore this is said to be a non-primitive. Am I clear? Okay. So fundamentally primitive unit cell and the non-primitive unit cell. Primitive unit cell, that means carries only 1 lattice point, and if it is carries more than 1 lattice points, these all are belong the title of non-primitive cell. Let's go further part of the crystallography. So here I am using the same analogy. This is a simple cube, that means 4 atoms are at the top, 4 atoms are at the bottom. This is just the last picture and the very first picture are identical, only the actual packing density of the atoms are very close to each other. One atom surface is touching to the another atom surface, and therefore they are said to be a condensed matter, that what I said in the very first lecture. So atoms are very closely packed, sabhi atoms are very closely packed, that is what the mean of solid. So primitive unit cell must having only 1 unit cell, and there can be a different choice for the lattice vector. So यहाँ पे अगर आप देखो तो उससे ज़्यादा है. अगर अंदर वाला atom little bit larger compared to the corner atom, so क्या होगा कि void की size छोटी है. अब उसकी वजह से ये जो कॉर्नर वाले एटम है that get separated. You can look at here, it is not touching to each other, and over here it's touching to each other. So it's depend on type of atoms and the closing pack setup, and according to that this is. But the nutshell story is that the corner atom contributing to your unit cell, that is 1/8 portion. If it is in center, then it is contribution as a whole. If it is on the wall, it would be contributing to the half. That we will even see in the next lecture as well. So let us go to the varieties of the lectures, varieties of the crystals. Then look at here, I am again putting the unit cell, and unit cell, that means just to giving an idea that what is the alpha, beta and gamma between A and B, that is gamma, then alpha and then beta. So it's the anti-clockwise. Okay, for just one reference, which is A and which is B and which is C, one beta is showing here. So for that you are getting an idea. I think the same setup you had learned in the 12th grade standard in the solid state topic. I think it was belong to the chemistry, and now it belongs to the physics. So more or less the story will be same, but we will go in a more detailed part of it. So if it's A, B and C are equal in alpha, beta or gamma, they are 100% orthogonal to each other, and the size of this A, B, C are equal, so it is a cubic structure. Then we can having the tetragonal. In case of a tetragonal, it looks like, you can say it's something like a bricks, where width and breadth and depth are identical, but height is different. So height is different, but the base is the very much square. So A and B are equal, but still they are very much right angle. So it is a cube, and this is a cuboid, right? ये घन है तो ये लंब घन है, something like that. Then you having a orthorhombic. This is a very common and well known. So this is all are mismatched. So something like, I can give in an example like a matchbox. हमारी जो माचिस तिली वाली जो बाकस है, उसको हम गुजराती में बाकस बोलते हैं, या तो मैच बॉक्स. So which having a width is different, height is different and length is different. So you can look at here, the width is different, the depth is different and height is different. So lattice parameter A, B, C, all three are different, and still it's a 100% geometry. So alpha, beta, gamma are 90, so it's a 100% orthogonal, which is called orthorhombic. Then the story comes around with the same ideology. A is not equal to B is not equal to C, but now let you push from this side or that side or top or bottom, so it becomes a squeeze matchbox, right? So A, B, C is still not equal. Alpha and beta are still 90. That means this angle and this angle is still 90, but this angle you can look at, this is not 90. Gamma is not 90. Okay, so this is gamma, and gamma is alpha and gamma is this two are the bottom angle, and this angle is, but this is not 90. This is what mentioned over here. Okay, now hexagon is a well known setup, and if you look at minutely, let me show you here. This you can see the dark phase here, right? Then it looks like exactly a tetragonal, right, where C is not equal and A and B is equal. So basically hexagonal is a 3 combination of a tetragonal. Can you look at? So this is a very beauty of a crystallography or the solid state physics. The same crystallographical structure, that is a fundamental crystal, that is hexagonal, but you can also look at through the different window that it is a combination of, or 3 tetragonal facing to each other. So this is one dark zone, this is a rear one, this is another tetragonal, and this is a third tetragonal, where everywhere you are finding A and B is equal. You look at here, the A and B is equal, right? This is A, let us say, and this is B, but this would be its C. If I talking about this dark one, so this is A, this is B, and the vertical will be the C. So A is equal to B but not equal to C. And or other way of learning, that is, it looks like a hexane ring, benzene ring. It's a hexagon pattern. I misspelled. It's not hexene, but it's a benzene. It is a hexagonal ring, one ring on top and one ring on bottom, and then you can combine all the corners, and that becomes the hexagonal. Yes, my dear friends, you have to also learn how to draw this particular crystals, because if I wish that your exam would be objective, then there is no need of drawing anything, because there would be an objective test. But if it would be a conventional offline test, then this would be a definitely a one fundamental question oftenly asked in the exam, that discuss the crystal and crystal structures of a solid states phase. That means you have to start with what it mean by crystal, what are the varieties of the crystals, that is the 7 type of crystals, and I will go with the further part of it also. That also you are aware, but let us discuss point by point. So you have to go up to that point. Okay. So alpha beta, that means the angle between B and C and A and C, that is alpha and beta, that would be over here is pure 90, but gamma is 120. So the face angle that becomes, so this angle or any particular angle of this hexaring, if you will check it up, then it would be the 120. So that is what the hexagonal. Then the rhombohedral, it's again 100% squeeze related to the cube, because when you squeeze it, because it's A, B and C are equal, but when you push this cubic structure from this side or this side, then it become the one of the angle become denatured. So alpha beta is 90, but gamma is not 90, right? The orthorhombic to monoclinic, it is also similar to the squeezing of something, but where the beta is getting denatured, over here the gamma is going to be denatured. And the triclinic, where all are mismatching, right? So all are mismatched, that is case of orthorhombic, and you are squeezing the orthorhombic such that so alpha, beta and gamma all are disturbed. That means none of them are 90, none of them are equal, and that is what the mean of triclinic. Okay, so in solid state physics, in condensed matter, the fundamental 7 crystals are there. This fundamental crystal are further split up into another 14 category. Okay, don't consider that 7 2s are 14, because some of the crystals having a split up like a 3, some of the crystals having a split up like a 4. So it's depend on their symmetry. The first question arises, how this 7 crystals are reorganized in the 14 shapes. This job is done by Augustin Brevis. He was an Austrian physicist, and he has given the idea about the each fundamental 7 crystals are how going to be represent in the further shapes, and that is how a varieties of number of lattice could be. So basic structure is still same, but just reorganization of the atom, and still symmetry and periodicity is sustained, is remain intact. That is what the mean of Brevis lattice. Brevis lattice is just a representation of a lattice point of this 7 fundamental crystals. माने आपका अल्फा, बीटा और गामा and A, B and C are still with the geometry of a cubic only. We are not disturbing that, but we are just reshufflement of the atom's position, and that gives us a freedom, and that gives us even the permissibility of a periodicity within your lattice space, and that is why it is called another 14 varieties of the Brevis lattice. Just to honor the scientist, this space group of lattice is referred as the Brevis lattice by his name. Okay, so what exactly? Let us say Brevis lattice is if you look at here again, a cubic, tetragonal, orthogonal, rhombic, monoclinic, triclinic and hexagonal. So I write it cubic, rhombohedral, tetragonal, and monoclinic, orthorhombic, triclinic and hexagonal, where hexagonal this 4 crystals having only one variety, that is a rhombohedral having only one possibility of I mean they doesn't have the rearrangement possibility of a lattice. Similarly triclinic doesn't have, and hexagonal doesn't have. Whereas in the case of cubic, this is very well known. I am pretty sure you are definitely aware about it even in your 11th and 12th grade chemistry, that this is all 4 corners, then 4 corners plus 1 is in center. So in this number of the available atoms or lattice point is 1, so it's a primitive unit cell, but the rest 2 part of a cubic unit cells are non-primitive. If you look at here, 4 are on the corner on top, 4 are corner on the bottom, so it's a 8 on corner, so that contributing 1 lattice point plus 1 as a whole inside, so it's a 1 plus 1, so it's a 2 atoms are there, or 2 lattice points are there. Similarly here it would be a 4 lattice points are there. So this would be a 2 non-primitive. Okay. Now in case of a tetragonal, again there is a 2 kind of the setup is a, one is a body centered and another is a simple. So this is simple cube, so this is called the simple tetragonal. This is called the body centered cubic, so this is called body centered tetragonal. Same way in case of orthorhombic, there is a 4 varieties are there, Brevis lattice. One is a simple orthorhombic, Another is a top or bottom orthorhombic. The third one is the centered orthorhombic, and the fourth one is the face centered orthorhombic. If you look at each face carries a 1 atom or 1 lattice point. माने यहाँ के जो 4 फेस है आपके, तो चारों फेस जो सराउंडिंग 4 फेस है, यहाँ के जो 4 सराउंडिंग फेसेस है, एक लेफ़्ट साइड वाला, एक राइट साइड वाला, एक पीछे वाला और एक फ्रंट वाला. सो एक फ्रंट फेस, एक रियर फेस, एक लेफ़्ट फेस, एक राइट फेस, चारों के चारे फेस में आप एक एक एटम देख सकते हो या एक एक लेटिस पॉइंट. सिमिलरली एक ऑन टॉप, 1 लेटिस पॉइंट ऑन टॉप एंड 1 लेटिस पॉइंट ऑन बॉटम. तो ये अगर आप रखोगे एटम, अगर ये पीरियोडिसिटी मेंटेन है, सो इट इज़ अ पार्ट ऑफ ब्रेवाइस लेटिस, बट स्टिल स्ट्रक्चर इज ऑर्थोरhombic. I have shown this 3-1, that is a cubic, tetragonal and the orthorhombic, where the cubic having a 3, so these are the 3 possibility of the lattice set Brevis lattice. The tetragonal having a 2, one is a simple and one is a body centered, so that is a 2, and this is a orthorhombic, there is a 1, 2 and 3 and 4, so there is a 4 possibility. Okay, and now let's look at on your right hand side of your Brevis lattice picture. Then rhombohedral, that means rhombohedral having only one possibility, so that is 1, just a simple. Monoclinic having a 2 possibility, one is a simple monoclinic and another is a top and bottom monoclinic, and the triclinic again having a simple, so it's a 1 option, and hexagonal also having a 1 option. So out of these 7 fundamental crystals, you have 1, 2 and 3, that is a rhombohedral, triclinic and the hexagonal, that doesn't have the any further variations of the lattice, whereas highest one with the orthorhombic, where you having a 4 varieties of a Brevis lattice. Then the second highest is the cubic, which having a 3, and tetragonal and monoclinic having a 2, tetragonal and monoclinic having a 2. So I put it in the middle part of it. Anyway, so this is known as a Brevis lattice. Thank you so much for paying attention. Stay home, stay safe, be focused, and please learn all the online lectures carefully. Good luck.